Let's practice with geometric Brownian motion that we use for modeling of stock prices. So we can think of individual assets, we can think of portfolios after we introduce information also about the covariances between pairs of assets, but we also use geometric Brownian motion in option valuation. So we will model underlying the behavior of underlying instruments in option valuation, and in this case we will focus on equity exposure, so this would be mostly about stocks. So we already had an introduction to geometric Brownian motion during our lecture and during our meetings in pre-pandemic times. So just for review, this initial exercise. So from practical point of view, we are interested in how to apply this tool, how to apply this knowledge about the solution to stochastic differential equation for practical purposes in Microsoft Excel and Visual Basic. As usual, we'll start with assumptions about the behavior of assets. So we want to know the drift, the mean version, and we want to know the volatility. Volatility, of course, will mean standard deviation. And our first example was about using this annual assumptions or assumptions of annual values to this framework, to this our final equation for logarithmic rate of return. So first thing to remember when you look at or when you analyze the formula for logarithmic rate of return is that you can decompose this into two parts. So the first part would be based only on assumptions. So scaling, usually it would be scaling down from annual assumptions to some other intervals like daily observations, monthly, and so on. The second part would introduce stochastic oscillation around our trend defined by this constant part. So let's start with the constant part, and in this initial exercise we want to simulate daily rate of returns, daily logarithmic rate of returns. So if I have drift equal to 6% per year, then my daily would be equal to this 6% divided by total number of trading days, and as you know we use 252 days in a year. In case of volatility, if we want to scale it down, we need to remember about this square root rule, so we can linearly work with the variance, but in case of standard deviation we need to incorporate the fact that this is square root from second central moment, so we actually have to divide our annual volatility by square root from also total number of days, 252. And the first part of our equation, the average mean in this logarithmic rate of returns would be equal to drift minus half of the variance, half of the volatility squared. So this is our constant part, right? This is the first part of our equation, precisely this one, assuming that index t here is already incorporated into this division. Second part is about stochastic random numbers, or applying random numbers to generate the stochastic part. This WT is this Wiener process, so independent observation from normal distribution. If we want to apply this in Microsoft Excel, we use normal standard inverse distribution. So it's already standardized distribution with a mean equal to 0, and then we will scale it to our assumptions by multiplying this later on by our volatility. So first in this array we're gonna simulate just this winner process, so normal standard inverse distribution with random probability. So we use random function. Random function is about giving us random numbers from uniform distribution bounded by 0 and 1. So if you apply it to standard distribution, you'll get values from the inverse normal, from this horizontal axis in normal distribution that we can use as an input to our function. So now if we combine this stochastic part and this constant part, our logarithmic rate of return would be first, we'll use first this constant part, plus second it would be winner process times volatility. Right, so this is gonna be an array filled with logarithmic rate of returns of some asset st, of some asset s, where t is equal to 1 in this case. And if we want to apply this logarithmic rate of returns to prices, if we start with 100, then the price for the next day, if we have logarithmic rates, would look like this. We use the base of natural logarithm to simulate the behavior of prices, and of course logarithmic rate of returns are independent because each observation, each cell uses different random number from normal distribution. In case of prices, we have this path when we use prior price as a base to calculate the new one. So we apply new independent rate of return to the price that we calculated in a previous simulation. Alright, so this is a very simple approach, and of course just for practice I want to show you how you can make it maybe more efficient in Microsoft Excel. So again, we have assumptions about the behavior of our asset, and then we will use just slightly different method to incorporate this time index more efficiently into our calculations, because we have assumptions about annual data. So the 6 year is this mean drift for the whole year, and this volatility 24% is for the whole year. But if I want to say daily observation, I need to divide it by 252 days. If I want monthly simulation, I will use 12 months. For quarters, I will use 4. I can use semi-annual, or I can stay with annual data. Right, so if I have this list, I can name this range here. So I can use this range, and I could call it interval, for example. Now if I have my list in name manager interval, and this is gonna be the simplest approach with one dimension only. So I have one array for my list. So now I can use this list for my assumptions here. Take a look. One example is to use data validation here. Data validation, and in data validation you can select a list that is used in a particular cell. So if you have a name for your range in Microsoft Excel, and our name was interval here, so I use interval, and now I have this list that I can just pick some particular value. Now the only thing I should do would be to use it in our calculation for this t-index. So our t-index can be equal to 1 over number of intervals, number of subperiods in a whole year based on this assumption above from the one that user chose. So if I have number of days next to, or number of subperiods next to my list, I can use Vlookup function. So a function that will look up for my value and then will return a value in the same row, and in our case it would be value from second column. So if I look for a daily here in my array, then if I choose second column, I will look up for daily, and second column would be 252. If I choose monthly there, it would be 12, and so on. So additional optional range lookup, we want to have true if we have this sorted in ascending orders, or if you want to find an exact match, we use false. In this case this is false, we have just strings, just text here, so this is how it's gonna look like, right? So I have 1 over total number of subperiods based on what user chose here. So if I have quarters, I will scale it down to 1 over 4. If I have dailies observation, that's my part of the year. And now I can just write it down in, again, similar approach to this one, or I can just use one formula to get this function in just one cell. So if you look at this formula, you can see that I have this drift minus 0.5 times my volatility raised to the second power, so times variance. Now I need to multiply this by my index t, so this is gonna be my index t here, and I need to add, what I have to add? I need to add volatility adjusted for index t. So I have my volatility times, and now because I have just standard deviation, I need to use square root from this index t, and I need to now use my normal standard inverse distribution with random values. And this is my total function. This is my constant part times index t plus volatility scaled down times normal standard distribution for this winner process. So this is my function. And of course, if you want to apply it to the day, to the some particular price, that's it. So it's of course the same, but it's just for practice, just for training. I'd like you to see this. The next step will be incorporating this function in Microsoft Excel, in a Microsoft Visual Basic Editor, right? So this exercise is like about introduction to Visual Basic, when you need to think of inputs that you want the user to provide your function, to use in your function. And in our case, the user will give us assumptions about the behavior of a price and interval, and maybe initial price if we're interested in price. And we should write this all in one function in Visual Basic Editor.